Hi everyone. So my name is Alice and I work at the consultancy firm Virtual Manufacturing, and my role is mainly within digitalization and Industry 4.0 solutions for customers within production and the logistics sector. And today I'm presenting a project that we are a part of, which is called Collective, and it's an EU-funded project which aims to bring sustainable, smart and energy-efficient buildings to the people. So what is Collective? And the Collective stands for the Collective Intelligence for Energy-Flexible Systems. And we are based in 6 countries, and we are 14 partners, which you can see over there. And we also have 4 pilot plants where we can test our management system. We target 3 levels of end users. The first one is what we call the facility owners, which could be somebody owning an apartment. And the second part is manager of buildings, which is the person handling the building with the apartments in it. And the third level is maybe a government, a county, or a city, which handling more buildings, more of a cluster. And our pilot buildings, where we are testing out our solution, are based in different geographical zones based on environment. So we can see that it's fitted towards all of Europe. And it includes schools, healthcare centers, campuses, big buildings that makes up maybe 40% of what we have in Europe today. And from Virtual Manufacturing's part, our task is to build the human building interface and also the dashboard for the Collective. So what are the challenges? Like, why are we doing this today? And it's mainly because we have seen that malfunction of buildings are often related to energy systems. And this is quite a big problem in Europe, since 75% of all the buildings that we have are not that very energy efficient. We also know that climate change and extreme weather make it hard for us to control the energy flow in big scale, and especially in urban situations like here or in Gothenburg or any other city. And it depends on, we have such a complex way when urbanization, humans, and the climate interact together. It's hard to find a scalable solution that can handle that energy flow. Yeah, that's what I just said. And we also see that the smart energy solutions that are on the market today are quite costly, or they require advanced IoT systems, which makes them hard to scale up. And the development for solutions that handle climate change, mitigation, and also discuss how to adapt to them successfully lacks. And it's not very cost efficient, and the computational requirements for these systems are so high that it's hard to scale them up. So our solution is that Collective implements, tests, and qualifies our management system based on scalability and operable. The methodology consists of us hooking up household appliances and the energy systems, so we can use our algorithm that we have developed to monitor all of the systems. And then this approach allows us to have homes that are fitted for our needs, but at the same time also contribute to a community that is more energy saving. And in the end, we believe that this will contribute to a more livable planet and more sustainable climate. And see if I can make this work.
75% of the buildings in Europe do not use their energy in the best possible way. They are not as smart as they could be. Currently, only a small number of existing buildings are smart, meaning they can adjust to the users, to the climate variations, and to the needs of the energy system. By following the principles of collective intelligence, we can upgrade and democratize the smartness levels of existing buildings. And we can do that at a low installation cost. In brief, through collective intelligence, we will smart up your appliances and heating and cooling systems while lowering your energy bills. What is collective intelligence? We can see great examples of collective intelligence in nature. Birds, fish. When alone, they find themselves limited. But when they move in groups, they help each other to survive continuously changing and sometimes dangerous environments using simple communication techniques. In general, they are stronger together rather than alone. Through collective intelligence, the interaction among individuals creates a greater smartness at the group level. Thanks to our user-centric platform, at Collective, we create a community of smart buildings, in which each one of them becomes an active element of the energy grid, generating benefits for the entire building community. This is how we make buildings and energy systems in urban areas more efficient, smarter, resilient, and greener. With Collective, we will bring all European households into the 21st century. Learn more at collective-project.eu and follow us on social media.
So the project objects for this case is to create a seal-based energy flexible network that ensures low installation cost and maximum data security. We also want to have cost-efficient components, meaning that the sensors that we're using need to be competitive in Europe and available for all types of households. And the system will be tested in 14 buildings, as I mentioned earlier. And this is to make sure that the different climate zones in Europe are covered and that our system is fitted towards the requirements. And we also want to achieve a non-invasive environment monitoring, meaning that the sensors that we are putting up should not interfere with the person's normal day-to-day life. And in the end, we also want to have a smart design which is user-friendly and that helps you maximize your energy savings. And this is the target of our project. So on average, we want to reduce the energy usage by 16%, and we want to save 0.2 to 0.3 euros per square meter in cost savings. And we also want to increase the satisfaction by 15% and increase the demand flexibility by 24%. So for the first part of our project, we have only focused on the two first levels of users, meaning the facility owners and the building managers. And this could be, for example, the apartment building and owners, but also a school with different lecture halls. And we have used the sensor multi-sensor units to measure pressure of the air, the humidity, and the temperature mainly. And then the data transferred is done over SMQTT to a local database which is run on a Raspberry Pi. And we have chosen SQLite as the database as it's very light-based and it's also independent, making it easy for us to adapt to any company or government that want to use it in the future. And the human building interface has also been done and also got an interactive dashboard. So Virtual's involvement is to do the human building interface in the dashboard. So that's the part I'm going to discuss now. And the most important thing with the dashboard is that the users have an easy way to manipulate between how they want to set their indoor environment, they want to be able to look at the data and customize their KPIs. And the interface needs to collect data from both different facilities and a full building, but not more than one building at a time. So this is how the interface looks. And to the left here, you can see the tabs in the dashboard. So we have user login, logout. We have the dashboard, which is like the home page. Then we have the scheduling tab, sensor information, and also the feedback. So for the dashboard tab, you can customize this however you would like. But often we show a picture of the layout and also where you have put up sensors, how many maybe. You can see some of the sensor information, like temperature, if that is what you're interested in. And you can also see outdoor information. And then we have the scheduling tab. And this is where you can see both weekly, Monday to Sunday, but also time, so over a full day. And what you see here, the white box that says 20 and on, that is the manual mode, which means that the first level user, the facility user, can choose on their own way how they want their indoor environment to be. And then we have RE, which is the resilient mode. And resilient mode is the collected, it's the collected performance of the whole building. So when you put that one in, you want to be resilient towards the climate based on how the whole building is performing. And then we have comfort mode, which then again just relates back to the facility user. So there you can decide, put it in the most comfortable indoor environment for the facility you are in right now. And it's the same for eco mode, but then it's based on economical savings. And then we have the sensor information tab. And here we have collected all the information you might need for the sensors. The serial number, what they are measuring, if they are running low on battery, if they're battery driven, which channel they broadcast on, and when they latest received or sent the data. And we also have the feedback part, which is important because we are still under development, so we are in a great need of collecting the feedback from our users. So that wraps up the collective initiative and where we stand right now. And a lot of the partners in this project have used this project to leverage to their own, to their own business area. And for virtual manufacturing, that would be gazpacho energy. So we want to do the same that we do with smart buildings, but for manufacturing plants. And the USP might be a bit different when it comes to manufacturing plants, since we are more focused on energy savings based on cost, and maybe not that much on human living preferences, to be honest. And we do this by measuring mostly machine performance, how much electricity machines and different processes require. We look at if you have heat exchangers or boiling pans to drive your manufacturing process. And we also look at doors or windows or big gates that are open and closed a lot, and see how that affects your indoor environment. So how this works is that we are a consultancy firm, so we want a plug-and-play solution. So we want to be able to go out to our customers and do projects. So maybe just monitoring the energy consumption over 1 or 2 weeks or months. Or we can also deliver a full-scale solution that they can have forever. So the important part is that we find sensors and ways to monitor performance that is easy to implement, but also easy to remove if that's the case. And we also need to think about how are we transferring this data? Is it important to do it in real time, or can we collect it and then analyze it on afterhand? And often we see that when we go into big customers, we are not allowed to send data out of their security walls. So we see that we want to be able to collect a bigger amount of data on a local server and then bring it out and analyze it on afterhand, so it doesn't have to be sent over any cloud server or similar. Then we have Gazpacho Energy, which is our software platform, which is similar to the collective platform, but we want to balance maybe production towards energy cost rather than like human living conditions, I would say. So like traditional balancing of production usually consists of when can we get in material and when we want to be just in time, or what balancing mix we have. But now we also want to have like a multi-variable solution that thinks about when is it cheapest to produce based on the energy that we can buy. So that is how the analytics tool will be used, and we are developing our own algorithm for this. And right now it's in the stage where it just brings in a lot of data and helps us look at it in an easy way. But for the future, we want to have some sort of predictive tool that helps us tell us that, okay, if you look at the energy market today and the climate or the situation in the world, we suggest that maybe you should change your production rate or when you're going to produce based on those parameters. And this is our toolbox when it comes to sensors. And we work a lot with motion detection. This is to see if there are people at the actual facility or if we can shut it down. And also to see how often are windows, doors, and gates open. Then we have Wi-Fi controlled light bulbs, just to make sure that we don't waste too much energy on lighting. And then also machine monitoring sensors. And that can be anything from just measuring the current to the grinding or when they have to change out the tool on the machine. And then we have the decision tree, which is what the algorithm should help us do. But right now, we as consultants work with this more manually. So we start with collecting data to derive facts, and then we think about, do we need to run this equipment? If we can take action and say no, then we switch it off or we scrap it, sell it. But if we need to analyze it further, we move ahead to, can it be run at a different time to lower the energy tariffs? And if we can take action here and say, yes, we can run it at a different time, then we move the activity to a night shift maybe. But if we need to think about it a bit more, then we think, is the equipment the most efficient one? And again here, taking action could be upgrading or replacing, but it could also be, should we outsource this activity because it's not cost efficient? But if we are reflecting, then the final step is to think about, is it really cost efficient based on energy when we sell the product? So are we getting the money back based on how much energy we use? And then either we have to update the costing template so the product price covers the uses of energy, or we need to look back and start to gather more types of data because we are lacking something. There's something we don't see. And the user interface, like the dashboard that we are using, is quite similar to the one that Collective have been developed. But I think a bit more KPIs. We want to see production over time. We want to be able to compare to maybe the last week, the last decade, the last year. And we also want to see how many products, units do we produce per shift, per energy amount or cost for that part as well. And in the end, we think that the benefits of this will be, of course, a more streamlined production. But since we talk a lot about emission rights and how much you can let out now, this is a very good way to become more sustainable and keep your competitiveness in the business. And in the end, we also hope for a more sustainable planet, of course. That's all.